Okay, everyone, so when calculating cell voltage, we'll look at an example. So let's say we were looking at that copper-zinc reaction from before. So we have our reduction and we have our oxidation. So we can look up the value for these half reactions. So these are values that are just simply from the reference sheets in your textbook. So our cathode half reaction, which is our reduction, minus our anode half reaction, which is our oxidation, and we end up with a positive voltage. So a positive voltage indicates that we have a spontaneous reaction. A negative cell voltage means that it would be a non-spontaneous reaction. Okay, so here is another example. So we have a following galvanic cell is set up below. So here is our standard. So remember that this is our cathode and here is our anode, right? We're going to write the half reactions for each corresponding voltage. So we're going to look the half reaction for reduction, the half reaction for oxidation. We're going to write the overall redox reaction, so the two half reactions combined, and determine the potential cell voltage of the electrochemical cell. So first we need to determine what reaction is what. So however, you could look at this with which one is the strongest reducing or oxidizing agent. However, we know that the cell notation, this is our cathode, which means this will be our reduction half reaction. This is our anode, which means it will be our oxidation half reaction, right? Just by simply knowing these steps. So keep in mind, right, this is a platinum electrode, but the electrodes will simply indicate the type of reaction for us. So even though platinum is not in this reaction, we know that hydrogen ions are going to be undergoing reduction because it's in the cathode half cell. So let's just going through that again. So here is our oxidation half reaction. So solid aluminum is becoming aluminum ions. And this is the value from our textbook. And we have our reduction of our hydrogen ions, and again, a value from our textbook. This just so happens to be the standard. So when you're writing the overall redox reaction, it's important to know the same rules apply when you were doing the IT for balanced reactions before. The total number have to be equal for lost and gained electrons. So here, before we can add these two half cells, we need the total number lost to be equal to the total number gained. So we need lowest common multiple between 3 and 2, of course, is 6. So we would multiply our oxidation half reaction by 2, which is shown here, and our reduction half reaction by 3. And then we can add them together, and of course you cancel out any terms on either side. Now, even though we multiplied by factors here to get the overall redox, when you are calculating your potential voltage, you do not multiply your E values by the factor. So even though we took this and we multiplied it by 2 and we multiplied this by 3, you do not do that to the actual voltage values. Okay, so it stays exactly as is from the reference tables.